Hello everyone, welcome to the course on data structure and algorithm. In this video we are going to see the topic queue. Now queue is something which is very familiar. Everyone is familiar with queue. For example, if you go at cinema for buying a ticket, you would form a queue like this. The simple concept is whoever comes first will get served first, and whoever comes last will be in the queue, in the last position of the queue. So there are basically two ends. The person who gets served will go out from this end, and the person who comes new will add into the queue from this end. So we are having a front end and we are having a rear end. So insertion is normally done from the rear end, and the deletion means the removal of the item is done from the front end. So this is the simple concept. So it is a two-ended data structure. Now let us try to understand queue. So basically it's a linear structure. So as we know, the stack is also a linear structure. Queue is also a linear structure, because over here the stuff goes in a linear way. In case of stack also, the stack was also a linear structure, because in that case it was also growing in a linear way. The second thing is it's an abstract data type. As we know that integer, float, character, these are primitive data type, whereas the queue, then stack, these are abstract data type, because these are not readily available. Users create them. User creates them. So that's why they call it abstract data type. So queue is an abstract data type, stack is an abstract data type. Then the third case is it is an ordered list. Ordered means the sequence is very important. Supposing 10 comes first, so 10 will go out first. Then if 20 comes after 10, 20 will go out after 10. So this ordering is very important. In case of stack also it was important, because if the 10 is pushed first, it will go last. Then the third part is it is first in first out, so, or first come first serve. For example, element 10 is inserted, so in the queue it is inserted in the beginning. So this is the beginning. Then comes, let's say, 20. So 20 is inserted after 10. Alright, and this is to go in this way. So insertion will be done in this way. Then comes, let's say, 30. So 30 is inserted over here. Right. And now if 10 is served, it will be removed. So now the queue would look something like this. Now we have 20 and 30 only, because 10 has already been served. So 10 has gone. So now 20 is on the front. So it is first in, first out. Whoever comes first, he or she goes out first. So sometimes they call it first come first serve also, or less popularly it is known as last in last out. So this 30 is last in, so it would go last. So FIFO and FCFS are very common terminology for queue. Then comes insertion and deletion. In case of stack, if you remember, we used to call push and pop. So over here the insertion operation is called Enqueue and deletion operation is called dequeue. So Enqueue and dequeue are very common name over here for insertion and deletion. Now let us compare stack versus queue. So if you remember, stack was something like this. We had a few elements like 10, 20, 30 and 40. So 10 came first. So 10 will go last, because you know that push and pop is done from one end only. So, and this is nothing but we call it top. So right now top is 3, because if it's 0, 1, 2, so top is over here. It is pointing to 40. All right. So push and pop is done from one end. So in this case it's a linear structure. In queue also, if we insert 10, then 20, then 30 and then 40, so it would look something like this. So deletion would be from this end, insertion would be from this end. So this is your front end and this is your rear end from where you insert. So both the structures are linear. This is also linear, this is also linear. Second, both the structures are ordered, because sequence is important. For example, if you wish to remove something, 40 would be removed. If you wish to remove something from queue, 10 would be removed. So this ordering is important. Now stack is last in first out, means the 40 was inserted last but it will go first, whereas in this case 10 was inserted first, so 10 will go out first. So this is first in first out, queue is first in first out, whereas stack is last in first out. Now in case of stack we have only one end. If you look at this, we have only one end. So pushing is also done on the top of the stack and popping is also done from the top of the stack. Whereas in case of queue we have two ends. You know, from front we remove the elements, we delete the elements, and from rear we insert the element. So there are two different ends in case of queue. And insertion is called pushing over here, push operation, whereas in case of queue we call it enqueue. And deletion we call pop, and in case of queue we call it dequeue. So now let us try to understand this operation from program point of view. As I have said that there are two different ends, front end and rear end in case of queue. So now let us try to understand different operation. First is enqueue. So enqueue means insert. So if you wish to insert anything, you need to specify the element. Let's say if you specify 10, so 10 would be inserted. So with enqueue you need to specify what element you wish to insert. But with dequeue you don't need to specify element. Why? Because it would be removed from the front only. Whoever came first will go out first. So for dequeue you do not need to specify anything. Then if you wish to know who is on the front, then for that you can have a function like front or pick. So it would not remove anything, but it would just tell you that which data item is on the front. Now if you wish to check whether the queue is full or not, for example in this queue suppose the size is 5, because there are 5 elements, maximum 5 elements can be stored. And now suppose if I store 10, 20, 30, 40 and 50. So now the size, the queue is full. Now what if I wish to add 60? So no, I cannot add 60. Why? Because the queue is full. So we'll check the condition also. And the last part is the queue empty or not? So for that we'll have to, supposing this is the situation where there is no specific item in the queue. So what if you wish to delete something from this? What if you wish to execute dequeue? So you cannot execute. Why? Because there is no item, so you cannot delete anything from it. So these are few functions that we will be doing in our programming, right? So let's start doing something. So the size of this queue is, let's say, 5. Now initially when the queue is empty, the front and rear are -1, because if we take these as index 0, index 1, index 2, index 3, index 4, size is 5, so ranging from 0 to 4. But when there is no specific item in the queue, then front and rear are -1. So this is something that you need to remember, that when there is no item, the value of front and value of rear would be -1. Now supposing we have a function like enqueue2. Now because this is very first item, what we'll be doing, we'll be inserting in the front, and then this both the pointers, front and rear, green is front, blue is rear. So front and rear both are set to 0. So front equal to rear equal to 0. So both are set to 0 in the very first position. Now supposing a second item is inserted, 13. So that would go after 2, because this is first in first out. So 2 would be in the first position. But now in this case only rear pointer would be incremented and front pointer would remain there on the very first location. Now supposing I am adding one more item, let's say -4. In this case also the rear pointer is incremented to this. So now front is still 0, but rear is equal to 2. So 0, 1, 2. Front is pointing to 0th location, rear is pointing to second location. Now supposing, what if I remove something? Now remove means which item needs to be removed? The item which came first. So 2 came first, so 2 will be removed. Now in this case the front pointer would be now pointing to 13, because now 2 has gone. So 13 is now at the very first location. So whenever now we remove something, 13 would go. So in this case we change the pointer this. So now front is equal to 1 and rear equal to 1, because front is pointing to 1 and rear equal to 2, sorry. So now this is the situation. Now let's say I wish to add 19. So in this case 19 would go after -4. So now 19 is over here. So the situation is front is at 1 and rear is at 3 because 0th location has already been vacated. Now next is, now what if I wish to insert 10? So 10 would go over here at the last position. So now front is still at 1 but rear is at 0, 1, 2, 3, 4. So rear is at number location 4. Now suppose if I wish to enter, let's say 5, but now you can say that now there is no more space available over here. So now this 5 will not be added and it would give an error overflow. Now one may think that we do have some space over here, but this space will not be used in a simple queue. For that we will be having another concept of circular queue. So in case of simple queue, this space is there but we cannot utilize. So this is a limitation of simple queue, regular queue. Alright, and this limitation would be removed in our forthcoming topics of circular queue. So now this 5 will not be added and it would give an error message of overflow. Now if you carefully look at this, see there are few conditions which are very important from program point of view. So front equal to rear equal to -1, that means that queue is empty. The queue is empty. So this is something what you need to remember. Now if see, look at this over here, the front equal to 1. So this is 0th location, first, second, third, fourth, and now 5th. So if now your rear equal to 4, or can I write something like rear equal to size -1? Alright, because what is size? Size is 5. So if rear equal to size -1, that means the queue is full and you cannot add anything into it. So these are two different situations. When the queue is empty, when front and rear both are -1, then the queue is empty. When rear equal to size -1, when rear is pointing to the very last element, then it is full. And when front is equal to rear, now this is a very interesting concept. When front is equal to rear, then there is only one element. For example, let me show you a simple thing. Supposing over here at this point of time, let's say this is a simple concept. So at this point of time we use DQ. So what will happen, this 13 would go, and then let me use a green pen so that it would be easy. So now this would be over here. Now again if I use DQ, what will happen, this will also go and now this would point over here. Now you can see that blue and green both are pointing to same location. So this is a situation where there is only one element when front and rear both are same but not -1. If they are -1, then it is empty. If they are -1, then the queue is empty. But if they are not -1, for example in this case 0, 1, 2, 3. So in this case front is equal to rear is equal to 3. So if this is a kind of situation, if you get it, in that case you have only one element. So this is something what you need to remember, right? So now let us move ahead. So what are those applications of queue? For example, you have a network like this. For example, you have a common printer attached over here and you have multiple computers in that network, and the printer is being shared by these different computers. So if you have multiple requests, for example this computer number 1, computer number 2 and computer number 3, if they provide requests, let's say R1, R2 and R3, if they provide requests for printing, so in that case what this printer would do, okay, because it cannot print all these requests at a time, so it would put those requests in a queue. For example, if R1 comes first, so it would put in R1, then R2, then R3. So it would create a queue like this, and then R1 would be served first. So first print would be from R1, then R2 and then R3. So this is one example of queue. And later on we'll see that sometimes if let's say something is very important, alright, so in that case there is a concept like priority queue also, that we'll see later. Then So instructions waiting for the turn to get executed by processor. So if there is only single processor, but there are multiple requests from different programs for their instructions. So processor is only a single, but programs are multiple. So in that case also we can have a queue. All right, and in this queue we can put all those requests, and whoever comes first will be served first, whoever comes last will be served last. So this is a simple example or application of queue. Now let us try to implement queue using array. We can also implement queue using linked list, but in this video we'll be seeing implementation of queue using array. Now look at this. See, this is Enqueue function. Enqueue is, we know that. What is Enqueue? Enqueue is addition something into queue. So initially, let's say this queue is empty. Initially, supposing there are 5 elements, the size is 5, all right, but the queue is empty. So we know that in this case, if I take 0, 1, 2, 3, 4, all right. So initially, the front is equal to rear is equal to -1, all right. So if this is the case, check this out. If this is the case, all right, and then what you are supposing, you have something like Enqueue. Enqueue, let's say 10. So if this is the case, what we'll be doing? We'll be inserting 10. But in this case, now front and rear both will be set to 0. So if front equal to -1, rear equal to -1, that means if the queue is empty, all right, and if the element that you wish to insert is the very first one, in that case front and rear are set to 0, and the element, let's say at 10, so that 10 is added over here. So this is the case where the very first element is added, all right. Now we have another situation. For example, we have a queue like this, having the same size 5, all right. Okay, so let's say front and rear are initially set to 1, -1. Let's say now 10 is inserted. So now this is front, all right, front equal to 0. Then 20 is inserted, 30 is inserted, 40 is inserted, and now 50 is also inserted. So now rear equal to 4, or rear equal to size -1. All right, so this is the situation. Now in this situation, if we wish to insert, let's say 60, all right, what will happen? It will check whether rear is equal to size -1. Yes, it is equal to size -1. So what it will print? It is not possible to insert any more element. So it will print the it is overflow, or the queue is full. So this is the situation where queue is full. So you cannot insert. And then, so these are two rare situations. What if the queue is empty? What if the queue is full? And then we have a normal situation. All right, we have a normal situation wherein supposing now the normal situation is something like this. We have 5 elements, all right. Then let's say there are 3 elements, 10, 20, 30. That means front equal to 0, front is pointing to 0, and rear is pointing to location number 2. And in this case, if I wish to enter 40, all right, if I wish to add 40 into it, what will happen? The rear is incremented by 1. So now instead of 2, now rear is 3. Rear is first incremented, and this 40 now it is copied into rear. So now this 40 is copied into rear. So this is the normal situation. So now we have in and all 3 situations. First is queue full, second is queue empty, and third is the regular normal situation wherein it's not full or not empty. So this is how the Enqueue function works. Now let's talk of the second function, dequeue. In dequeue means removing. Now the very first thing is, let us check whether there is any item or not. So if the queue is empty, that means we know that front and rear both are equal to -1. And if this is the situation, and if you try to remove something, it would not be possible because there is no data item. So now if front equal to -1 and rear equal to -1, that means there is no data, so it will be underflow. So this is queue empty situation. Right? Now front equal to now second situation is, now let me remove this. So this, now second situation is there is only one data element. For example, there is only 130 over here. That means front is equal to rear is equal to 0, 1, 2, 3. So this is the location number 3. So if there is only one data item and if you remove this 30, what will happen? Then front and rear, because once you remove the last item, it will be the vacant one. So in that case, what you would be doing, front and rear are set to -1. So front and rear are set to -1. So this is the second. And now the third and regular case. Third and regular case means it's not empty and it's not the last element. So in that case, what you will do, for example, we have something like 20, 30 and 40. That means front is pointing to position number 1 and rear is pointing to position number 3. Rear is pointing to position number 3. This is position 0, 1, 2, 3, 4. And now if you remove something, so it would be removed from where? It would be removed from the 20. So it would be removed, so 20 would be removed. So in that case, now which is on the front? So now this is on the front. So front is equal to 2. So we'll be incrementing. So look at this. So we'll be incrementing the front and we'll be printing what the previous value was. So now if we summarize this, now this is the situation where queue is empty. So when queue is empty, there is no point in deleting anything. You simply print a message. This is the situation when only one data item is there. So only one data item, that means we'll be setting front and rear to -1. And this is my normal situation. Alright. So these are the three different cases that we'll be dealing with in case of dequeue. Now peak. Peak means I just want to know what is there in the front. So let's say I have something like this. Let's say I am having 10, 20 and 30. That means front is equal to 0 and rear equal to 2. Rear equal to 2. That means if, so in case of peak, let us check whether front equal to -1 and rear equal to -1. That means this is the empty. So in case of empty, you would not be able to return anything. So just simply print a message empty. But if it is not the case, what you would be doing? Queue front. Queue front means you would be displaying 10. You will not be removing. 10 is still there, but you would be displaying. Look at this. In case of dequeue, what we did? We did front plus plus, but we don't do front plus plus over here. We simply display it. So the item will remain there. It will only be displayed. All right. So that is the third function, peak. And the last function is display. If I wish to display all the elements, I don't want to remove anything, but I just want to know what is there in the queue. So let's say the situation is something like this: 20, 30 and 40. All right. So front is at the, if I write the position 0, 1, 2, 3, 4. So front is at position 1 and rear is at position 3. So I'll be running a loop from this to this, from front to rear. So look at this. So I'll be running a loop I equal to front and I is less than or equal to rear plus plus, and then I'll be printing QI. So this is how I'll be printing all 10, 20, 30. All these elements will be printed. But if there is no data item, how do I check it? If front and rear are both are -1, in that case we will not be able to print anything, but we will just generate an error message that queue is empty. So display is a function where we start printing from front and we'll go all the way up to rear. So we'll start printing from front and we'll go all the way up to rear. So now this is the complete program. This is the enqueue function that we have seen. This is the dequeue function, display function and peak function. And this is our main. We have set the size equal to 5. This queue is the array, and front and rear are initially set to -1. That means initially the queue is empty. Now look at this. So let us say that there are 5 different items. All right. So when I put 10, so 10 would go here. All right, and front is equal to 0. Then when I put 20 and 30, look at this. 20 and 30. So 20 and 30. That means now rear equal to 2. And then now when I use display, what will happen? From front to rear, that means 10, 20, 30. This would be displayed. Then if I use peak, you know, peak gives you the front location, that means 10. So this 10 would be printed. Now when I use dequeue, what will happen? Dequeue means empty out. So this 10 is gone. Now this front is pointing to this 20. So now this is gone, front is pointing. And now if I do peak, what will happen? Peak will give you 20. So that 20 will be printed. And if I print display, what will happen? Now we have only two elements, 20 and 30. So 20 and 30. So this is something what you are going to get as an output. Alright, so let's see. So let me remove all this so that you can see the output. So initially 10, 20 and -5. These are three elements that we are going to get by this display function. Then peak means it will give you the front location. So front location is 10. Then after removing, when I remove dequeue, so what you will be removing? Dequeue, that is 10 will be removed. Then peak, now if you see, then 20 is on the front. And if I now display, so 20 and -5 will be displayed. So this is the simple implementation of queue. Now in our next lecture, next video, we'll see the circular queue. Till then, thank you very much all of you for watching this video.